Hi everyone, welcome back again, and we are going to see a very interesting topic, that is about indicators. In cities and in all places now, we are used to indicators. So when a vehicle just goes before you and they just show you right, if the light goes, we know that the vehicle is going to turn right or left. Okay, such indicators are here to tell you whether it's an acid or a base. Such indicators are called as acid base indicators. Yet there are other things. See, sometimes you know that the person is turning left or right, but do you know, does he indicate that he is going to go say 10 kilometers this side or 15 kilometers this side? No. But how far he goes, we do not know. But there are some indicators in chemistry, they are called as universal indicators, which can tell you how acidic or how basic a solution is. Whether it is a strong acid or strong base or weak acid can be found out by universal indicators. Okay, so this basis of these indicators is totally based on something called the pH scale. Okay, this pH scale is made of 14 divisions. This is called as the pH scale. It's made of 14 divisions. Okay, so this is basically, what is this pH? What does pH mean? From the letter H, pH means hydrogen ion concentration. Okay, so the concentration of hydrogen ions is given by the measure called pH. 0 to 7 is what is called as acidic pH. So an acid would have 0 to 7. It could range from 0 to 7, rather 6.9, and this pH of 7 is called as neutral pH. It's neither acidic nor basic. From 7.1 to 14 is called as alkaline or basic medium. Okay, so these are the different readings, like 0 to 7, 7 to 14. Now we should also know one important thing. From 7 to 14, see, sometimes when your hard work increases, your marks will increase, directly proportional. Okay, so if a pH is 14, the base is strong. If there is a pH of 8 or 7.3, the base is weak. Okay, so that is based on the value, you can find out the strength of the base. But when you come to this side, when your play time increases, your marks will decrease. It's indirectly proportional. If you start playing a lot, marks go down. Now here, if a pH is 6, then it is weakly acidic. So just because its value is more doesn't mean that the acid is strong, but it is indirect. So if a pH is 1, it is strongly acidic. So if pH 1 will denote strong acid or strongly acidic, pH of 6 would denote a weak acid or weakly acidic. Here it is different, pH of 7.5 weakly basic, pH of 14 strongly basic. So this we should remember with difference between the bases and the acids. Okay. Now what does this universal indicator mean? Okay. Now when you come to the before going to the universal indicator, we can also see the types of acid base indicators. Now in our vehicles we have only lights to show. There are no different lights like green lights or orange lights, okay? But here this acid base indicators will give different colors in acid medium and basic medium. There would be different colors. So based on that you find out whether it is acid or base, and there are three indicators that we usually see. The first one is litmus, okay, which we saw earlier in the previous videos. Then we have phenolphthalein. This also shows different colors. Then we have methyl orange. Okay, so these are the three things that show different colors in acid and basic medium. So here this becomes blue to red litmus in the acid, and in the base it is red to blue. Okay, that's about litmus. Phenolphthalein is colorless in the acid medium, whereas in the base it becomes pink in color. Methyl orange is pink in the acid medium and it's yellowish or orange in the basic medium. This is what we are going to see now. So we take 3 test tubes for acid and we add acid to all the 3. Okay. So to the first one we are going to introduce blue litmus paper. Put it inside, it turns red. Okay, so that shows that it is an acid. Now the next one we add phenolphthalein. It still stays colorless. That means it is an acid. When we add methyl orange, it becomes orange in color or pink in color. Now let's go to the base. Let's take some base in 3. Okay, this is sodium hydroxide. Now I take red litmus paper, introduce it into this. Now it turns blue, so that means it's a base. Then we add phenolphthalein. It turns pink, that means it shows that it's a base. We take methyl orange. It becomes yellow in color. Okay, so these are the different colors that we get with different indicators that shows whether it's an acid or a base. Now we move on to the universal indicator. How far, whether it is weak or strong. This is based on the pH scale. This is the universal indicator. Okay, this has different colors. You must have seen these glucose strips that we used to have. When you dip the strip into the blood or the urine sample, it will give different colors, and that will show the amount of sugar present in the blood or the urine. Like that, when you dip this strip into this acid or base, it gives different colors that shows the pH of the solution. For example, you have this universal indicator. See, this strip has different colors up to 14, just like this one. 1 stands for strong acid and then 14 stands for strong base. Now, when I introduce this one of the strip into a base, it's almost, we compare this with this and you get it somewhere around 13, pH of 13 and 14. Okay. Then if we take one more and introduce it into the acid, it's slightly pinkish, maybe because it's too dilute. Okay, that means pH of 2 or 3. We could also find out the pH of water. See, this is water and it's yellow. This water is yellow. If yellow and slightly greenish, you could compare it with this. It's somewhere around pH 6. Okay, this is the work of the universal indicator. So, this is the difference between an acid base indicator, which would only show you the difference in colors, whereas an universal indicator would also show you the pH approximately. It may not be accurate, but approximate. With this, we conclude our topic on indicators, and we will be moving forward to salts in the next video.